Chapter by doing some comparison back to amphibians. And we may do, that's a good one. How about salamanders and newts? Who wants that one?
Won't change.
No. Salamanders and newts. Think about that. We'll finish this up on Thursday and make sure everybody got their assignment out there and pick a deadline. So first, we start with a comparison back to the amphibians from the reptiles. We're adjusting more to terrestrial environment for sure. Going from amphibians to reptiles. Yeah, reptiles still need water to drink, but a lot of them live in very arid regions and they're very good at conserving water. So the first reason they give on 571 that a major difference is the type of eggs that's produced. Instead of a membranous egg shed in water from the amphibians, now we have an amniotic egg that has some kind of leathery shell to it. It's either leathery to a hardened aspect, but mostly leathery. Number two, thicker and more waterproof skin. Well, if you think of a crocodile and the skin on that, and the frog that we're going to dissect in a couple of weeks, and well, it's paper thin compared to really, really thick. So thicker skin, better able to survive that terrestrial environment. Number three, rib ventilation of the lungs. Well, the fact that reptiles have ribs and amphibians don't is big enough reason right here to list that one. And well, also the reason we do frogs and then turn and do like a pig to represent an upper level vertebrate is a diaphragm, ribs and diaphragm. Number four, stronger jaws. Frogs' jaws, amphibians' jaws typically for gripping prey, not crushing and grinding. And then you think of something in this reptile category and you're thinking of gnashing of teeth and grinding and the whole shebang. Number five, high pressure cardiovascular system. We're going from 3-chambered hearts to 4-chambered hearts and a much higher pressurized system. Number six, water conserving nitrogen excretion. A lot of the reptiles live in arid environments, so they're very good at conserving water, even to the point of storing fat in their tails to pull metabolic water from over time. Some of the lizards do that. And then we have number seven, expanded brain and sensory organs. In other words, their brains are getting bigger. As we get closer to us being the last group that we'll look at here, we would hope we would be the smartest one on the upper echelon of that massive pyramid, right? So there's your 7 differences from reptiles to amphibians. The first order we want to look at on 574 is order Testodines. Who took this group? Who took my turtles? All right, here you are. There's some unique things that they point out in here that a lot of us don't even know, never thought about. May leave here and still not care, but you're going to hear it anyway. They lack teeth. The modern turtle's jaw is tough, keratinized plates for gripping food, and I'm telling you, you don't want to stick your finger in there and let them snap at it, because some of them will leave you stuck. Turtles are enclosed in shells consisting of, test question on your study guide right here, a dorsal carapace and a ventral plastron. Dorsal carapace and a ventral plastron. You'll go on and look through the reading over on 575 and 576, and they'll talk about the different types of shells. You have hinged shells from the old box turtle that can totally conceal itself inside the shell. When you get into the big snapping turtles, like in figure 26.6, this turtle cannot totally pull itself within its shell and hinge up. This turtle leaves vulnerable parts exposed, so this turtle fends for its life, is snapping at tormentors and can inflict painful bites if he gets hold of it. If you ever stuck a pretty good sized stick in front of one of them, they crush it in two pretty quick. So there's a major difference in some of the types of turtles and their shells. And the shells can inhibit the way they breathe sometimes. And they talk about that on 575. It says air is drawn in by contracting limb flank muscles to make the body cavity larger. Exhalation is also active. Now typically breathing in for us is the active process, And breathing out, exhalation, is a very passive process as far as energy reserves. Turtles are going to have to actively do both because of the way their shells are made and the way their bodies are compressed inside of these shells. So that's what they're saying when exhalation is also active. And it is accomplished by drawing the shoulder girdle back into the shell, thus compressing the viscera and forcing out the lungs. So normally that would just be relaxing what we use to inhale with. They're going to have to force both in and out, their muscle contraction to do both. So the turtle's brain is small. I know you'd have never guessed that. But never, in fact, it never exceeds more than 1% of the body weight. The cerebrum is larger than that of amphibians. The cerebrum is conscious thought, and you actually should get more size as we move up this totem pole. We're going from amphibians to reptiles to birds. There's a lot of things about it. We hear the term bird brain all the time, right? We really shouldn't make fun of bird brains because there's a lot of things about bird brains that beats us. Yeah. So, and then we get to mammals, which you should get into larger cerebrums each stage you go. Turtles have a middle ear and an inner ear. They may have a fairly small brain overall, but they can learn a maze about as fast as a rat. And then as far as hearing, they have a middle and an inner ear, but a lot of turtles are actually just mute. They don't hear anything. So these are some neat things you can bring out about turtles and find exceptions to different species. Most turtles are mute. Sound perception overall among turtles is just poor. Most turtles are mute. Compensating for poor hearing is a good sense of smell and color vision, so they actually see color quite well. We see on 576, if you can get past their pornographic picture at the top of the page, that turtles are oviparous and fertilization is internal. Using internal copulator organ, the penis, the turtles complete a full-fledged oviparous by laying the eggs outside. Now, oviparous, again, can be internal or external fertilization. In this case, this is an internal fertilization, still laying eggs on the outside. Now, an interesting feature of turtle reproduction, and we're going to see this at the end of the chapter because it's right the opposite. In turtle reproduction, there are no sex chromosomes. It's totally based off the nest temperature. So, nest temperature determines sex of the hatchlings. In turtles, low nest temperatures produce males, and high nest temperatures produce females. We'll see that exactly the opposite in crocodiles and alligators at the end of this chapter. Marine turtles. Some of them they call leatherbacks, are largest, attaining a length of 2 meters and weight of 725 kilograms. Yeah, that's a big turtle. You know how many kilograms in a pound? 2.2. That's exactly right. So you can double that 700 and something, and we've got a massive piece of turtle out here. One that you could ride to town if you're not in a hurry. Some land tortoises may weigh several hundred kilograms, such as the giant tortoises of the Galapagos Island. Darwin liked those. He studied those significantly. Low metabolism explains 150 years of duration. They can live up to 150 years. And then here's where they talk about the different makeup as far as the shells. The familiar box turtle is hinged, it says, and even difficult to wedge a knife blade in there. They tighten it up pretty good. Then you get some of the other turtles, the leatherbacks, common snapping turtles, have reduced shells, making complete withdrawal for protection impossible. So snappers have their defense, as their name implies. They're going to snap at tormentors to try to ward off. They are carnivorous, living on carrion, fishes, frogs, crayfishes. They don't live just on fish. They live on fishes. Did you notice that? Okay, just wanted to point that out. I know that still bugs you to say fishes. Have y'all entered fishes into your new vocabulary now? Okay. So they eat a variety of things is what they're saying. And an alligator snapper lures its unwary fish to its mouth by having a tongue part that looks like a worm. Look at that picture at the right-hand page. See him hidden? He's pretty camo in that picture, isn't he? He's got his mouth open, You've got this little tongue part, looks like a worm, so a little fish comes by and says, oh, look at this nice worm, and goes after it. It's all over. We got something. That's just wrong, but that's the way it survives. Next order, squamata. I think that order is properly named, don't you? When you think of lizards and snakes, do you not think of squirmy things? So it's a properly named order. This group is kind of unique in that they tend to have, especially a lot of the snakes, have what's called kinetic skulls. Some of the lizards do too, but these kinetic skulls allows them to eat things much larger in diameter than they are. They can actually unhinge their jaw, use the flexibility of their skin and muscles to swallow something much larger than them, and then hinge their jaw back out. They'll actually take and push their lower jaw back out, then when it comes back it pops into place. So, exceptional skull mobility is what they're talking about on the first page. Now, as we go to suborder Sauria, the lizards, they do a lot of lizard-snake comparisons here. And I have a few test questions about lizard-snake comparisons, so we'll point some out as we go. Of course, they mention the geckos. We commonly know that as the gecko. But geckos, I mean, if you've ever seen one gecko, they all look the same, but unique little lizards, I'm telling you. There's some fly-catching machines. And too bad our climates will not allow us to just kind of have open windows and open, because there'd be geckos just be cruising around in the ceiling in here. A few years back, several of us here at the college in the science and math department went to the island of Hilo. We had signed up for a week-long class studying volcanoes through the University of Hawaii, and the motel we checked into right on this bank there. You just walk in, restaurant open, there's no windows, everything's open. The restaurant's open, walk in the lobby, it's open, and there's geckos hanging around, sitting on the corner, sitting on the side of the chair you're sitting on. There's no flies. There's no fly. You can sit in the restaurant and eat for hours, and there's no flies. If you found a fly, it would probably shut down the whole island. But, I mean, they're insectivores, and they take care of it. But I'm sitting around and said, man, this is science, and the biological end of it was amazing to me, but I mean, the volcano end of it was pretty amazing also. But there's geckos sitting around waiting on some insect to come crawling by. He's going to be dead in just a little bit. So, go from the geckos, which are very boisterous, very noisy, if you will. Small, agile, mostly nocturnal, with adhesive toe pads. That's why we can see them on the ceiling, behind the lights, anywhere they want it to be. And they walk upside down and on vertical surfaces. Then we have the iguanids, including most familiar New World lizards, often brightly colored and ornamental crest frills and throat fans, and remarkable marine iguana of the Galapagos Island. And I know Discovery's done several documentaries on these iguanas of the Galapagos Islands. Then you have skinks. And there's actually some poisonous skinks out there. It's one of the few lizards that is poisonous, besides the Komodo dragon, I think, is another one. Beaded lizards. There we go. So the skinks, elongated bodies, armor of tight-fitting osteoderms, and reduced limbs in many species. Then we have monitors, very active predators. They're large, so they're going to eat things rather large. And they actually move quite well for their size, and they're the largest lizards. Among them are the largest lizard, the Komodo dragon. And then the chameleons, which we've all heard of the chameleons, and they have a long sticky tongue where they can reach out there and just slap that fly right off your nose. That's what they like to do, and they've got a picture of one there, and it of course changes colors with their surroundings. So there's several groups there. Now here they start listing some differences between lizards and snakes. It says a great majority of lizards have 4 limbs and relatively short bodies, but in many of the limbs are reduced, and a few, such as glass lizards, have no limbs at all. So glass lizards probably close to a snake because snakes have no limbs at all, but lizards do have limbs, so that's an obvious difference. Most lizards have movable eyelids. Snakes don't. we get over to the snake section, they'll tell us that they have a piece of skin over their eye called a spectacle. You wonder where that term comes from with glasses. That's a snake's glasses, is the spectacle. It's actually part of the snake's skin. And as the snake's skin grows with age, when we get through most of the summer and we get into the dog days of the summer, you ever heard that term? Dog days of summer? Things are just hot and dry, and we're looking at August really. Snakes start shedding their skin, and then their spectacles are new. But up to that point, the closer they get to shedding their skin, the less they can see. Their vision's poor anyway. But when you start clouding up the eyes, they get a little agitated at the least thing, trying to defend themselves. They don't know really what it is, so but when you don't know really what it is, you're a little defensive. And so that's when snakes are most aggressive. So most lizards have movable eyelids, snakes permanent covered eyes with a transparent cap, and that transparent cap is called spectacle. Lizards have keen vision for daylight. Now, with exception, there's exception of the geckos. They tend to be pretty nocturnal, and they have a retina of mainly rods, so they see well at night. And let's see, when they tell you that in the next sentence there, geckos' retina is composed entirely of rods. Most lizards have an internal ear that snakes lack. Now, they say that here, say external ear, I said internal. Lizards have an external ear, snakes lack. Now, snakes do not have an external ear, but they do have some internal, they do have what's called an internal ear, and the bones in the ear. Although they don't hear, they pick up vibrations well, which vibrates through the bones of the body and is picked up in the inner ear, and so they make out noises. Now, precise noises and things, it's very, very difficult. Let's see, geckos are exceptions because males are strongly vocal, so most lizards are not going to say a whole lot, but geckos will, as we've seen commercial after commercial where the little gecko talks all the time. So we know that they are noisy. And they must, of course, hear their own vocalization. Other special species of lizards vocalize maybe in a defensive behavior, and that's about it. They list the Gila monsters in the next paragraph. Store fat in their tails, used during drought, provide energy and metabolic water. And then Gila monsters and their close relative beaded lizards are the only lizards capable of delivering venomous bites. So there's only two there that we really have to worry about there. Now, lizards typically they use the term ectotherms. The term ectotherm is assuming the temperature of your external surroundings. So lizards are not going to live in areas that get real cold and stay cold throughout the year. They're going to live in areas that tend to be more consistently warm. Now here we do get cold. They do somewhat go into some, I can't really call it hibernation, but they survive the coldness to find them on a December day sitting on a sunny rock. Is that not a common sight in Oklahoma? So, cold climates provide limited opportunities, so you're not likely to find them there. So reptiles tend to be successful in ecosystems that are less successful, if you think about it, deserts, warm, dry environments. So productivity is less. Reptiles tend to like those areas best. All right, moving over to suborder Serpentes, snakes. I think this is a good one, of course, lacking both pectoral and pelvic girdles. There's a lot to be said about these rascals. Different snakes all over the world, non-venomous as well as venomous. We're going to learn more about this as we get presentations together and throw these at us, and hopefully you'll learn things that you didn't know before. They're going to tell you right away the cornea of a snake's eye, lacking a movable eyelid, is permanently protected with a transparent membrane called a spectacle. So I'd already told you that. Together with reduced eyeball mobility, gives snakes the unblinking stare that many people find unnerving. Poor vision. Most snakes just have poor vision across the board. Now there are exceptions. There are some snakes that live in arboreal forest that literally live up in the canopy of the forest, and not being able to track prey by scent or heat detection. They have to see their prey up in the canopy of the forest to go get it. So they have excellent binocular vision. So there's always exceptions to these little weird rules that's out there. So good binocular vision for those. Now snakes have no external ears or tympanic membrane, but snakes do have internal ears, they're telling us. Recent work has shown quite clearly that within a limited range of low frequencies, hearing in snakes compares favorably with that of most lizards. That's still not saying much. Okay, so snakes are also quite sensitive to vibrations conducted through ground, and that's where most, I mean, whether you hear it or not, if something touches a bone in your head, you'll feel the vibration, won't you? And you'll actually pick up some type of noise or noise component through vibrations through the bone. That's what's happening here. Snakes employ chemical senses rather than vision. And a lot of, well, we've all seen a snake. Have you noticed the tongue going all the time? It's not like they just really hate you and sticking their tongue out at you all the time. They're picking up chemical senses. Forked tongues too, that's even worse, isn't it? The serpent at one time spoke with a forked tongue. That put us all in the bad shape we're in today. Of course, noticed he enticed the female. We'll go on from there. So, ended up, the forked tongue goes out, picks up chemicals that you've left behind, whether it's your finest perfume or BO, it doesn't matter, and sticks it right up in the roof of its mouth in the Jacobson's organ. And the Jacobson's organ, I swear, all the tongue does is go up there and tickle those 2 or 3 little brain cells up there and say, hey, wake up, there's somebody out here. And it determines whatever it is, whether it's good, bad, ugly, I need to eat it or get Sam Hill out of here. It makes a decision off of chemical senses. So that's the Jacobson's organ that's talking about. Not all snakes have this, but a lot of them do. Now, they list pit organs. We're going to talk more about that in a little bit. Look at different types of movement listed on 581. Different types of movement range, and there's pictures at the bottom. Lateral undulations, most common. That's what we have in most of our snakes around here. A concertina motion, it's like spring-loaded, so to speak. Rectilinear motion, and then there's sidewinder motion, which the rattlesnake sidewinder gets its name from that. It looks like it's going this way and it's going this way. Or maybe it looks like it's going this way and it's going this way. It'll fool you. And they list those as you go down through there, and it says most snakes capture their prey by grasping it with their mouth and swallowing it while it's still alive. Now, all of our non-venomous snakes, if they're not venomous, then they're either going to have to choke it to death or swallow it while it's alive, if you think about it. Our venomous snakes, they don't like to deal with the struggle, so they'll strike their prey, leave a little venom in them, let the prey run off, track them up with chemical and heat sensing devices, and then eat them. They're not fighting anything by the time they find them, okay? So what we have in a lot of our non-venomous snakes, if a snake's facing this way in the roof of their mouth, there's usually 2 rows of teeth that are slanted, just like that right there. You ever drive into an area that you drive across these steel spikes, and when you drive across them, they fold down, but you don't want to dare back up? That's what these teeth are. Things slide by them because they're angled like this, but they're not coming back. You know, you're swallowing something head first, and that's the way they'll swallow it, head first. And alive, it's got its feet down, it's pushing back, and it's going to push right back into these teeth, and it's not going to come back anymore. Once it gets it past the tooth, muscle sticks it past the next tooth, it's not coming back. So they've got it figured out. Now granted, they don't like to eat them where they're just struggling like crazy. So in some cases, I've seen black snakes take cotton rats and squeeze them till their eyeballs look like they're falling out. And I've heard this squealing noise. What is that? And I get to tracking the noise down and look over there, and this black snake's got this cotton rat just wrapped up, and all you can see is the tip of his nose and his eyeballs sticking out of this black snake. Literally reached down and picked the whole wad up, and the black snake is not turning loose. He wants this rat for supper. So stall him enough, suffocate him enough, whatever, but squeeze the weebie-jeebies out of him, he finally gives up, and then you have less struggle to choke him down. But once you get him down so far, they'll suffocate pretty quick and then the struggle's over. And I've seen snakes try to eat chickens. And they get the head and the neck down, but when they get to the body, well, that body's just a little more than they can handle, so they end up just spitting the chicken back out. Well, chicken's dead. They suffocated it. So sometimes their eyes are bigger than their stomach, that's for sure. So that's what they're talking about at the bottom of the page. And a lot of these snakes that like we're talking about here don't necessarily try to attack large prey like large rats. Mice, they list worms, insects, smaller prey is more what they're wanting to go after. Let's see, we're over on 582. It says snakes that first kill their prey by constriction usually specialize on large, often mammalian prey. So now we're looking at the constrictors. That the largest constrictors are able to kill and to swallow prey as large as deer, leopards, crocodiles. Now it's always amazed me that people would get a constrictor as a pet. Now how many times have you seen this? Why would you get a constrictor as a pet? I'll tell you a story, and if this doesn't change your mind about constrictors as a pet, I don't know what will. There was a case where this young lady had a pet constrictor, pretty good size at this point. And the constrictor quit eating. She would feed it rabbits or rats or whatever, and quit eating. And she kept it in a glass cage for quite a while, and occasionally it would escape, and she'd capture it and put it back in there. Well, it got to where the snake would crawl up in the bed with her and sleep in the same bed with her. But she still couldn't get it to eat. And so she took it to the vet, and the vet asked questions after questions, and finally he narrowed it down to this. He said, this is why your snake's not eating. Your snake is sizing you up for its next meal. Now you either get rid of it or keep it in its cage, or you won't be here to ask questions about your snake. Now how would you like that? Your pet's planning on eating you. Well, that's what they do. He's thinking, well, I can hold out on a little diet here and get me a big meal, and I won't have to eat near as much. Well, you've heard of little kids getting escaped out in California. It's happened several occasions. Something's under somebody's house. Look under there, and it's a constrictor that somebody lost or turned loose several years ago, and all the neighborhood pets have been missing. Somebody's kid goes missing out of a backyard. Wonder what it is? Well, it's a 20-foot long python and underneath a house. Why do we even want those? Well, they've got them in Florida, and they're moving this way. And it's all because of pets that people reach a point, they don't want to take care of them anymore, so they turn them loose. And they're not native to America, but they were adapting quite well. They're eating all kinds of wildlife, game, crocodiles, it doesn't matter, alligators, people. It's causing wrecks when they cross the road because you hit them with a car. It's not like hitting a black snake in Oklahoma. You hit a snake that big around with a car, it flips your car, tears your front end out. And it's causing it in Florida, and they're coming up this way. They're in Florida, Mississippi, and coming up this way. So don't be surprised if a constrictor don't show up in your backyard one of these days. Have to pull the old John Wayne out. Feel your hands. Mr. Constrictor. May have to. Self-defense. Now, leading us into the vipers here, they talk about, it says other snakes kill their prey before swallowing by injecting with venom. Less than 20% of all snakes are venomous. So you guys that got the venomous categories don't think you got off even because there's a lot of snakes out there. Although venomous species, this is going to make you want to move. Venomous species outnumber non-venomous species 4-to-1 in Australia. So I know where you're not moving to. Australia. Venomous snakes are usually divided into 5 families. Here they are. They're based on the type of fang that they have. Vipers, family Viperidae. Highly developed movable tubular fangs at the front of the mouth. This would be something we'd be familiar with, right? Rattlesnake, copperhead. water moccasin, or it could be a rattling copper-headed water moccasin. Around here, we make up names as we see them, right? The fangs lie in a membranous sheath when the mouth is closed. When a viper strikes, a special muscle in the bone lever erects the fangs as the mouth opens. Good picture here on the right-hand side. Where would you guess the discharge orifice for poison would be in a fang? Right at the end. That's my first response every time, right at the end, but it's not.
About a quarter inch up.
It's on the side. It's a slit up on the side. It's not just a little hole, it's a slit. And the reason it's not on the end, because this snake has got a bite through possibly hair, flesh, possibly fat, depends on what animal they're just biting, and it'll stop up the end, and then they can't discharge poison. So they have a solid penetrable point, and once they enter into the flesh, they discharge the poison out into the flesh. It makes sense once you think about it. Now, my first, just poison comes out the end of the fangs. That's not the case. And they can actually shoot poison out. They can open up and literally shoot poison quite a distance. Rattlesnakes can, I know for sure, because I've seen them do it. And you don't want them to shoot it in your eye. Now, there's other snakes like cobras that can do that. It'll go through the membrane. It's worse than, it's actually worse than biting you. Cobras can do that as well.
So it shoots out sideways?
They actually have pretty accurate forward somehow, not sure. So when a viper strikes, this special muscle delivers the fangs. And fangs are driven to the prey by the thrust of the strike. Venom is injected into the wound through a canal in the fangs. The viper immediately releases its prey after the bite and follows it until it's paralyzed and dead. Now, our pet vipers realize that they can track them down, so they bite them and let them go, unless they've chosen a bird for their prey, and they won't let go of a bird because they know a bird can fly and there's no way to track him. So they've got a little sense about them and what that they're actually trying to eat here. So now also you've heard the case where the small snakes are more venomous than the large snakes, or you may hear young snakes are more venomous than older snakes. It's not a generalized true statement, because the smaller, younger snakes, it's kind of like being potty trained. They've not yet learned to control their poison. Where a large snake can bite you 10 times and never inject poison. A small snake, if it bites you, it injects all it has. It's like he peed his diaper at night. He peed all he had, right? So, but now, which one would you rather inject poison in you if they're both going to inject poison? The little one. Just a little bit of poison compared to a whole lot of poison can make a serious difference. Now, in the state, well, in LaFleur County, there's never been a documented death from a copperhead bite. And one of the more serious ones was kin to you, Misty. One of the more serious ones was bit on top of the toe, and several days later they were this close to calling in an antitoxin. And I'm pretty sure they identified that as copperhead bite, I think. But she said it felt like a sting on top of her toe. And Josh takes a look at it, and there's two little prongs. Well, it's more than a sting. Good. Now, that's a copperhead. There's only been one documented rattlesnake bite. Of course, this is not counting the ones that didn't make it in to report, right? We don't know how many of those skeletons are still out in the woods somewhere. But one documented rattlesnake bite, and this is, you can almost call this self-inflicted. It was the guy's pet that killed him. He wasn't, he wasn't killing him to eat, he just tired of him, I guess. The guy ticked him off for the last time. The guy had been bitten several times by this snake and never once went to the hospital, didn't have to, because the snake chose not to inject poison. This particular time, the snake had it, unloaded on him. And oh, I've been bit before, it's no big deal. Geez, that sure does burn more than that last bite. Man, my arm's swelling, I better go to the doctor. He was DOA. So, I guess there's a lesson to be learned there. You don't want a pet boa constrictor. You don't want a pet rattlesnake. Who wants any kind of a snake for a pet? That's my question. Granted, there's good snakes and bad snakes, but geez, there's a lot of good pets out there. We've got kids for pets. So that's all the pets I need. That's enough to take care of. All right, so that takes us through the pit vipers. They actually, in the vipers, we have old world vipers that lack facial heat sensing pits. Among the latter are common European adders and African puff adder. You know, those had a terrible time getting over here on Noah's Ark. And the puff adder and the, what do they call the other one, the common European adder, when finally found dry land, and Noah opened the doors and said, "Go ye therefore and multiply." When everything was gone and he thought things were done, he heard sniveling in the back of the ark. So he tracked down the sniveling only to find a couple of adders in the back of the ark. And he said, "What is the problem? You've been on here freaking forever. I open the door and tell you to go multiply," and they look at him with these sad little beady eyes, and they say, "We can't. We're adders. They can't go multiply. They're adders." So it messed up everything. I'm sure he convinced them, though, because we have them today. He kind of, I guess, got it all straightened out, didn't he? And then among these as well, I know some of y'all didn't get that, I'm sorry. All best known North American venomous snakes are pit vipers, including cottonmouths, copperheads, rattlesnakes. Each year in the United States, approximately 7,000 bites from pit vipers are reported, causing about 5 deaths. That's the ones that made it back that died in the hospital. Second family of venomous snakes. Short, permanently erect fangs in front of their mouth. In this group, we have cobras, mambas, coral snakes, and kraits. Do we have any of these in Oklahoma? Yes, we do. We have coral snakes. Coral snakes are banded. They're banded with different colors, and there's actually a king snake in California that's banded very similar to this. But if the bands run in sequence of red and yellow, it's a coral snake, because red and yellow kill a fellow. Red and black venom lack. So there's kind of a little quote that people have learned over the years, and most people around here says, "Screw the quote, kill it, and then we'll figure out if it's poisonous or not," right? Yeah, here we go again. So this group of cobras and mambas, these are some serious poisonous snakes. Now we're not going to see cobras, and if we start having pet cobras over here and turn them loose, then somebody needs to be shot. Because we've got enough poison over here without some of those. But these snakes get so big and so aggressive, they'll actually hunt things down and not bite them once, they'll bite them 10 times, injecting neurotoxins. So people sometimes almost go immediately shot to death right there. Highly venomous sea snakes, they're in a third family, Hydrophidae, hydro for water. And the fossorial mole vipers, family Astra, Spidae. It's a big family. Usually have fangs similar to those of vipers, except the fangs are in the back of the mouth. And being in the back of the mouth, not a lot of these are extremely poisonous, although there's a couple of them that are. They really have to latch onto you good to get the fangs in the back of their mouth up there to inject it. So most of them are kind of poisonous to the prey that they eat. It's almost like it knocks you out long enough for me to eat you kind of deal. But there are a couple, the African boomslang and Savannah twig snake of Africa are very dangerous and have caused human fatalities. But they have fangs in the back of their mouth, not in the front of their mouth. So some major differences there. They talk about the different kinds of toxin. We mentioned neurotoxin. Our pit vipers here in Oklahoma has what's called a hemotoxin. Hemotoxins, what it does is break up red blood cells. Break up the red corpuscles, causes massive swelling and hemorrhaging. Loss of oxygen carrying capacity, puts a person disoriented pretty fast. The neurotoxin will attack different nerves. It can attack optic nerves, the one you don't want it to attack, and it will. The phrenic nerves, it stops your breathing, you're dead. Now, if you're in hospital care and it attacks these nerves, and we can obviously breathe for you long enough maybe to get the toxins out of the system. The neurotoxins are bad though. They're very difficult to overcome. And of course, our coral snakes, again, if there's any documented deaths due to a coral snake, there's not many. But they literally have to chew through your skin to get the injection into you. It's not a fanged snake. They have to chew through your skin to get it through to you. The neurotoxin is more deadly than the hemorrhagin, put it that way. If you get bit by a snake here in Poto, Oklahoma, and we take you to the hospital, they're going to treat you by way of IV and antibiotics. That's the way they're going to treat you, and they're going to watch to see where the swelling goes. They're going to use anti-inflammatories. They're going to try to build your blood count back up, but they're going to try to dilute the poison. And the faster they can dilute the poison, the faster they can make this go away. Now, why don't they use an antitoxin immediately?
Too scarce.
Well, it is fairly scarce. It's highly expensive. One vial of it's like 10 grand. And Poto won't keep it. Fort Smith, one of the hospitals in Fort Smith will keep it. I think they switch off on who's going to keep it because they keep it so long if they don't use it, they lose it. So that's just trashing 10 grand. But there's been cases where Poto has called Fort Smith and got it down here. And there's probably cases where they've actually had to use it. But the anti-venom itself has killed as many people as snake bites themselves. And it's because it's made of horse serum. And when it's made from horse serum, there's usually major allergic reactions injecting horse serum into human bodies. Horses have the ability to create antivenoms and we don't. So we use horses to do that. They finish up this part right here simply talking about the aggressive king cobra, 5.5 meters in length. This cobra is nearly 20 feet long, running between 18 and 20 feet long. That's a big snake. And it basically tells you that they'll estimated 50 to 60,000 people die from snake bite each year. Most of the deaths occur in India, Pakistan, Myanmar, and nearby countries where poorly shod people frequently come in contact with venomous snakes and frequently do not get immediate medical attention. So just what we've already said. Primarily the snakes responsible for this: the Russell's viper, saw-scaled viper, and several species of cobra. And you'll see probably those three listed in your top 10 killers. I'll look forward to that. Most snakes here, this is off your study guide here for sure. Most snakes are oviparous. Bottom line. Most snakes are oviparous. And then the American pit vipers are ovoviviparous. They don't have placental attachment, but they give birth to live young. Somebody didn't know that the other day in my hybrid class, and they brought a picture where they'd killed, I believe it was a rattlesnake they'd killed. No, it's a water moccasin. They killed a water moccasin just a couple weeks ago, and this thing was huge, and they cut it open, and it had like 27 babies in it. And it laid them out there. I mean, some of them were still in there, you could see it, and then they pulled some out and laid them out. There they are. No placental attachment, but they're living off an egg yolk, much like our shark will when we do the shark up there, okay? And then there's always an exception to the rule, very few, but there are a few that's possibly vivipars, possibly vivipars. We're going to skip the order Spinodonta. I do ask on the study guide 4 orders, I think, out of this chapter. So we had order for turtles, testudines. We had order for snakes and lizards, squamata. Now we've got order Spinodonta for this little lizard. By the time we figure this lizard out, he'll probably be totally extinct because there's only a handful left in the world. And then order Crocodilia is your last one. So if you have your study guide, right there is what you're looking for that. So we're in the crocodiles and alligators, and the alligator is much smaller. The crocodile can get up to about 2,200 pounds. That's big. They can eat large things, like we said earlier already. Crocodiles, on the study guide it asks what's the most aggressive reptile. That would be your crocodile. They're extremely aggressive. They describe them as having an elongate, robust, well-enforced skull and massive jaw musculature arranged to provide a wide gape And rapid, powerful closure. Teeth are set in sockets. Type of dentition is thecodont. Thecodont and dentition, much like the scales on their skin. Kind of like the sharks, they can actually replace a tooth if it gets pulled out or knocked out or tore out. Another adaptation found in no other vertebrate except mammals is complete secondary palate. What the secondary palate does is protect their breathing from having a mouthful of food, because they're not gonna chew up their food. They swallow it whole. They beat it up, mash it up, crush it up, and then swallow it whole. If it's large enough, it can actually keep them from breathing, but they have a secondary palate that still allows for an airway while their mouth is completely full. Crocodiles also share with birds and mammals a four-chambered heart that makes them more efficient. The estuarine crocodiles of Asia, Nile crocodiles, grow to great size, 1,000 kilograms, that's 2,200 pounds. Male alligators, very loud during the mating season. As crocodiles are oviparous, laying eggs out on land. 20 to 50 eggs, usually in a mass of dead vegetation, a compost heap, if you will. And as we said earlier, temperature of the nest determines the sex of the offspring. And they tell you that in the next paragraph says, incubation temperature of the eggs. Unlike turtles, low nest temperatures give you females. High nest temperatures give you males. Low nest temperatures, females. High nest temperatures, males. And you can differentiate crocodiles and alligators in the smaller by head morphology. In the last paragraph, they tell you that crocodiles have a relatively narrow snout, and when the mouths are closed, the fourth lower jaw tooth is visible. Well, I don't know about you, I'm not going to get close enough to tell you about the fourth lower jaw tooth. But yeah, a more narrow snout for the crocodiles, a more flatter, shorter snout for the alligators. So a little head morphology. I wouldn't worry about tooth morphology, okay? You might be getting a little too close for that one. Be brave if you tried that one. And then they go ahead and list the two cousins that whoever picks this want to be dealing with, and gharials, and what was the other one we called it? Caiman. Caiman and gharials, both listed there as well, so you'll want to put those in with the crocs and alligators. That finishes the chapter. You can turn me off there.